So section 2 is standard form of a quadratic function. Section 1 was vertex form of a quadratic function. And actually in section 1 I pointed out what standard form looked like. It's f of x equals ax squared plus bx plus c, okay? And here it is listed right here for you again. F of x equals ax squared plus bx plus c. Standard form is listed by highest degree term to lowest degree term. So that just means the squared term has to come first, the linear term or the x term comes second, and then the constant term comes third, okay? Now, the thing of it is, with standard form, the only term that has to be there for it to be a quadratic function still is the squared term. So this has to be there, okay? And it has to go first in standard form. The linear term, or the x term, this guy, doesn't have to be there. It could be missing. In other words, the b would be 0, okay? The constant term, this guy, doesn't have to be there either. It could be 0, okay? Which means we wouldn't see it. But that quadratic term, the squared term, must be there in order for it to be a quadratic function. If it's not there, then it's not a quadratic function, it's something else, okay? So the graph of a quadratic in standard form is still a parabola. In section 1, it was vertex form. It was still a quadratic function. It was still a parabola. This is also a parabola, which means we're going to be dealing with graphs that look like this or this, still in this section. The information we had in vertex form is hidden here, and that's kind of the bummer of standard form. Vertex form is really nice because the vertex is staring us in the face. We know all the information we need to know to be able to graph the parabola in our heads. We don't have that luxury here. We know that it's going to be a parabola, but we don't know everything we need to know about it when we're looking at standard form. We know some information, but not all of it. We can still find the vertex fairly easily, but we're going to have to do a little bit of work, and that's what's going to make standard form a little bit more difficult to work with than vertex form. The y-intercept is present in standard form where it wasn't present in vertex form, okay? Vertex form, you can't see the y-intercept easily. In standard form, you can. The y-intercept is the constant term, and you write it as an ordered pair, 0, c. And the c is that number right there. It's the constant term. So that guy is the y-coordinate in the ordered pair 0, c. So if you don't see the c in standard form, what would the y-intercept be? 0, 0. Yeah, it's an ordered pair, okay? And you can abbreviate y-intercept y-int. This will come into play later on. Okay, good there? All right, so let's move on. So this little chart that's up here has a summary of basically everything I've been talking about and then a little bit more. So the constants a, b, and c, those are numbers. We're not talking about the letters x squared and x. Those are the variables, okay? Just the constants a, b, and c are going to help us graph our parabolas in this section from standard form. So first of all, the graph of standard form, f of x equals ax squared plus bx plus c, and then it says a is not equal to 0, that graph is going to be a parabola. And that's just saying what I told you before. The a can't be 0, because if it was, then the x squared term would disappear, and that can't happen if I'm going to have a parabola, okay? The x squared term has to be there. Then it says if a is greater than 0, the parabola opens up, and if a is less than 0, the parabola opens down. Well, that's exactly the same thing as what we saw with vertex form. If a is positive, the parabola opens up, and if a is negative, the parabola opens down. That's just like what we were doing with vertex form, okay? In fact, the a is exactly the same as vertex form. If a is positive, parabola opens up. If a is negative, parabola opens down, okay? Same thing. So that's no surprise there, okay? And actually, the number tells us if the parabola is going to be skinny or fat also. That doesn't change either, okay? The axis of symmetry is the line x equals negative b over 2a. This guy right here is how we're going to get started as we're graphing these parabolas from standard form. So AOS is my abbreviation for axis of symmetry. The axis of symmetry, remember from last time, is x equals, it is an equation, x equals negative b divided by 2 times a. This is just from Algebra 1, and basically this whole section is a review of Algebra 1 with the exception of like one thing, I think. So you just have to remember that. X equals negative b over 2a and you're good to go. Okay? We plug in the b, we plug in the a, we simplify it down, and we have our axis of symmetry. Then the x-coordinate of the vertex, we remember from last time, is exactly the same as what we found for the axis of symmetry. So that means we have half our vertex already if we have our axis of symmetry. So then we can start writing our vertex. To find the y-coordinate of the vertex, we're going to take the x-coordinate that we found, which was negative b over 2a, and we're going to plug it into the function. Okay? So that's why you see that notation. Y equals f of negative b over 2a. All that's doing is it's saying the y-coordinate of the vertex is plug in the x-coordinate of the vertex into the function. All right? That's just directions on telling you what to do. So don't get confused by whatever that says right there. F of negative b over 2a just says plug in the number. All right? If the number you found was 3, you're plugging in 3. It's not meant to be confusing. Even though it looks complicated, it's not. And then the y-intercept we saw in the previous slide was 0, c. Remember that it's an ordered pair. It's not just a number. So the two graphs that we have here kind of illustrate that point. We have y equals ax squared plus bx plus c in both cases. The one on the left says that a is greater than 0, which means that our parabola is going to open up. The one on the right says that a is less than 0, which means our parabola is going to open down. Okay? So in both cases, we have x equals negative b over 2a. That just means that my axis of symmetry is sitting here. And if you look, it looks like the axis of symmetry on the one on the left looks like x equals positive 1. So that's great. To find the vertex then, I would take that positive 1 and plug it into the original function. Evaluate it, and I would wind up with my y-coordinate for the vertex. So here's the vertex sitting right here. It would be 1, comma, whatever. Okay? Looks like maybe negative 1. Right? So it's not hard math. It just takes a little bit of math to find the vertex, whereas in vertex form, the vertex is staring us in the face. Okay? Then we also have the y-intercept sitting right here in the equation, which translates into the y-intercept sitting right here on the graph, 0, c. Same thing happens for the graph on the right. We have negative b over 2a for the axis of symmetry, which we get from x equals negative b over 2a. So then that becomes the x-coordinate for the vertex. Then we take that number, whatever it is. For us, it looks like the axis of symmetry sitting here was x equals negative 1. So then this number sitting here would be negative 1. We take negative 1 and plug it into the equation, evaluate it down, and we wind up with whatever it is we get right here for the y-coordinate for the vertex. In this case, it looks like maybe, I don't know, positive 3.5 or something. Okay, I don't know. It doesn't matter, right? But that's what we get here for the vertex. We also have this c value right here, and that translates into this number for whatever the y-coordinate is on the y-axis for the y-intercept, 0, c. Okay? That's the idea. That's what we're going to be doing in this section, because we don't have the nice transformations from vertex form. We're going to have to do math instead to come up with these numbers. So standard form equations, it says, are a bit tougher to graph, but it's only a bit tougher. It's not that big of a deal. If you remember that points reflect across the axis of symmetry like we were doing in section 1, then it does simplify the math quite a bit. We're going to be just fine. Locate the axis of symmetry first by doing x equals negative b over 2a. Then find the vertex. You absolutely have to find the vertex no matter what. And find 2 more easy points. Usually it's 2, but if we run into a case where the vertex is way up at the top and the parabola opens down or vice versa, then we're going to probably have to find maybe 2 or 3 or 4 points just so that we get the parabola going all the way through the graph. Then reflect like we were doing last time and draw your smooth curve. Okay? Same idea as yesterday. Not a big deal. Okay? Just a little bit more math this time. So let's try this first one. The first thing we're going to do is find the axis of symmetry. So what you're going to do is write AOS. And then you're going to write x equals. And now since this is the first time we're doing this, I'm going to go ahead and write down the formula for the axis of symmetry as well, because the more you write it, the better it's just going to be. So x equals negative b over 2a. And also, since this is the first time we're doing it, I'm going to label what a, b, and c are in the equation. So a is here, it's always attached to the x squared term. B is here, always attached to the x term. And c is here, always the constant term. So now I'm going to plug in my numbers. So I go equals. Now it's supposed to be negative, so I'm writing the negative. Now what's b? B is 2. So I write down 2, and then divided by 2 times, and what's a? A is 1. I don't see the number, so it's 1. Okay, and then I simplify all that. What do I get? Yeah, it reduces down to negative 1. So now what I'm going to do is I'm going to write, this is x equals negative 1. So I'm going to rewrite this and kind of just formalize the answer. X equals negative 1. I'm writing it underneath where I wrote AOS. And then I'm going to put a box around it because this is just a good habit to get into, because later on in the section, we're going to be doing this anyway. So now my next move is to draw in the axis of symmetry as a dotted vertical line going through negative 1. So now the next thing I'm going to do is I have to find points, and one of the points that I absolutely must find is the what? I have to find the vertex. So now I'm going to set up a table, and the table this time is going to be more complex because the function is more complex. So I have to include 3 columns. So I have x, and then the middle column is going to be the function itself. So x squared plus 2x plus 3, and then y. The middle column is where I'm going to be showing my work, and that's just to help me kind of have an easier time of showing my work. It organizes the work and it helps me do things in my head rather than relying on a calculator. So now, how am I going to find the vertex? What number do I have to plug in? Yeah, so negative 1 definitely has to go in my table. And then I have a choice. I can go with numbers that are like 0, 1, and 2, numbers to the right of the axis of symmetry, or negative 2, negative 3, negative 4. Numbers to the left of the axis of symmetry. What sounds easier? Right. Now, before I put those numbers in there, there's one point that I can get for free right now. What point is that? The y-intercept, which is what? It's 0, 3. I can mark that right now. And because I have that point, I can also reflect it right now. So reflect it. And there we go. So we just got 2 points on this parabola for free without even having to think. Okay? Now, when I go to choose my numbers, I was going to choose 0, 1, and 2, but now there's no need to choose 0. Or I could choose negative 2, negative 3, negative 4, but now there's no need to choose negative 2 because I already have them. Okay? So what numbers do you want to pick? 1 and 2. Yeah. Those sound way easier to work with than negative 3 and negative 4, right? Okay, so we absolutely have to use negative 1 because negative 1 is going to give us the vertex. So we plug in negative 1, and I'm just going to simplify each term as I go. That way, then I can simplify each term and get my answer. So I plug in negative 1 of the first term, what do I get? 1. And in the second term, I get what? Negative 2, so minus 2. And then the plus 3 is just plus 3. So then I have 1 minus 2 plus 3. What's my result? 1 minus 2 is negative 1, and then negative 1 plus 3 is 2. So I can mark that. That's my vertex. Which way does my parabola open? It's supposed to open up. And with those 3 dots on there, does my parabola open up? Yeah. So I think I'm probably doing pretty good right now, right? Okay. So now plug in 1. What do I get for the first term? And then the second term? So plus 2, and then the plus 3 always. And what's my result? 6. So I can mark that one, and then I can reflect that one right away. And now, if I was to do the 2 that I thought I probably would need, I'm going to be way off my grid already. I'm already pretty much at the top of my grid. So there's actually no need to do that 2. It's not going to help me at all. So I'm done. Okay? Now I know that I can't go vertical because we talked last time about how parabolas are supposed to look. I can't draw a trash parabola. So I can't go vertical. I can't loop it over itself so that it's not a function. And I can't curl it over so that it's looking like a vase. I don't want to draw a lumpy one, and I don't want to have it have points on it, right? No sharp points. So I need to draw a smooth curve, and I need to be conscious about how I do this, and it needs to go all the way through the grid. So draw your smooth curve on there. Just start outside the grid, loop it through, go outside the grid, and draw arrows on the end, and you're done. All right, so let's try the second one now. What do we do first? AOS. What do I write? X equals negative 2 over 2 times, yeah, A is negative 2. So then we simplify that. One half is right. The top number is negative 2 because it's negative b. And b is 2, so it's negative 2. Okay, so we have x equals 1 half as our axis of symmetry. And like I said, I'm going to put a box around that because it's just a good habit to get into because we're going to be doing that anyway later on in the section. All right, now what do I do? Put that on there, on the graph. Now you don't need to change the scale just because you have an axis of symmetry that's 1 half. It's just going to go between 0 and 1. So let's put it on there. I'm trying to draw a dotted line here, believe it or not. There we go. And what's next? Make a table. So x, the function, y. Which way does this parabola open? It opens down. Good. And is there anything I can do on my graph right now? I can put the y-intercept on there right now. Where is it? Where? 0, negative 5, right. So I graph it, and what else can I do? I can reflect it. Now when I reflect that, it's going to only go a half a unit to get to the axis of symmetry. So a half a unit again puts it here. Now, if I can ever get the dot, there we go. While I just did that, I realized something. Where does the vertex have to be, given the fact that those two dots look like that? Okay, the parabola opens down, so the vertex has to be above it, but where? It's going to have to be on the axis of symmetry for sure, but where? Like, give me a proximity to those two dots. Close or far? Why close? Because those dots are super close together. That means that the vertex must be very close to those two dots. Okay, does that make sense? So I'm going to have to find the vertex in my table, right? The first point that I put in my table is going to have to be what? 1 half. And so because I have these two dots sitting here at a y-coordinate of negative 5, my result for when I plug in 1 half better be pretty close, but a little bit higher than negative 5 for y, right? That's kind of my thought there. And that's a nice way to check myself to make sure that the answer that I get is going to be right. Okay? Does that kind of make sense? Those are little things that you can do to help yourself as you go to make sure that you're doing things right. Now, I also am going to have to pick numbers. Now, we know that this thing opens down, and we can see that we're already pretty low on our graph. So am I going to have to pick a whole lot of numbers here? No, probably not. Maybe 1 is going to be good enough. So should I go with 2 or should I go with negative 1? Probably 2. Just went 1 to the right of what I already had. Okay? Make sense? All right. So let's get the 1 half out of the way. So I plug in the 1 half and I square it. The square has to happen first. Order of operations. 1/2 squared is 1/4. 1/4 times -2 is -1/2. Okay, 1/2 squared is 1/2 times 1/2. That is 1/4. Make sure you understand that. Okay, now 1/2 times 2 is 1. So plus 1. And then the minus 5. So now let's simplify that. -1/2 plus 1 is 1/2. Now 1/2 minus 5. -4.5. Now, usually in this class, we like to write things as improper fractions. So like, 9/2 or things like that, right? We don't need to worry about that here because we're just trying to graph it. -4.5 is way easier to try to graph than -9/2, okay? So you leave it at -4.5 and you plot that and you wind up exactly where we thought we should be. Very, very close to those two dots, but just above it. So what do you think? Are we doing this right? Yeah, I think so. So now let's do the 2, and this should be way easier. 2 squared times -2. -8. And then the next term, so plus 4, and then the minus 5. What do we get? -9. Now that's off our grid, but it's close enough to the grid that we can come up with a reasonable guess as to where we are. So 2, and then -7, -8, -9. That's probably somewhere in here. Okay. Now we got to reflect that, but be careful when you reflect it because we're only going 1.5 units to the axis of symmetry. So when we reflect it, we're going to go 1/2 and then 1. So 1.5, so then 1/2 and then 1, and that puts us right there. And that's good enough. We draw our smooth curve, arrows on the ends, and we're done. So the New River Gorge Bridge in West Virginia is the world's largest steel single-arch bridge. You can model the arch with the function that they give you here. And actually, I'm pretty sure that this is how they built the bridge. They made that function and then built the bridge around it. So where x and y are in feet, how high above the river is the arch? No. 516 feet is to there. But they want the height of the arch above the water. Okay, good, yeah. Look at the diagram over, so the graph here shows how high from the base of the arch to the top of the arch is. How high is that? 360 feet. And then the base of the arch to the water is 516 feet. So we have 360 plus 516 for a total of 876 feet. You can't tell from the picture. Yeah, the note packet doesn't do a good job, but the color picture here does a good job. You can see the difference. Just looking at this picture here, you cannot tell how tall that is. 876 feet, looks like FF, that's a feet. 876 feet from the base to the top of the arch, okay? But then there's structure of the bridge here too. So it's plus another something, right? And you don't know how much that is. It's clearly over 900 feet, right? It's probably more like 950 feet, maybe even 1,000 feet from the top deck where the cars and people are to the water. Okay? That's where cars are. Yeah, there's like semi-trucks and cars and all kinds of stuff on that bridge in this photo, and you can't see them because they're so tiny. Now, the second part of this question is, how long is the section of the bridge above the arch?
Just that section.
So just above the arch, yeah.
You can't.
If he says it's more like 1,000 feet, then it must be 200 some feet.
I'm pretty sure you can see it on this slide. It just wants above the arch. What's the length of the bridge above the arch? 1,600 feet. It's right there. From 0 to 1,600. So this distance right here is this distance right here, and they told you that's the length of the bridge above the arch. Okay? So that's just above the arch, though. We still have all this length here and all this length here. So the total length of the bridge is way longer than 1,600 feet. Okay? It's actually, this bridge is about as long as the length of our town. Yeah, so you can fit, like from the bridge coming into town to the turn leaving town, there. That's a big bridge, right? You can't tell from the picture. This is almost 1,000 feet up. And how tall is 1,000 feet? The bluffs outside of town are about 80 feet. Yeah. So identifying parts of a parabola or of a quadratic function without graphing. You don't need a graph to be able to do what we're doing here, and so that's what we're doing. First thing you do is you find the axis of symmetry using x equals negative b over 2a, okay? You don't need to graph it to know what the axis of symmetry is. Then you find the y-coordinate of the vertex, and you write the vertex as an ordered pair. So we have the axis of symmetry, AOS, and then we plug in the AOS to find the x. We have the x-coordinate then, so we plug it in to find the y-coordinate, and we write that as an ordered pair. So now we have two things. We have the axis of symmetry. We use the axis of symmetry, which is the x-coordinate of the vertex, to find the y-coordinate of the vertex. We write that as an ordered pair. Then we look at the a value. That's the number that's attached to the x squared term to determine if the parabola opens up or down. If it is a positive a, then the function will open up. Positive a value, the parabola opens up. Negative a value, the parabola opens down. If the parabola opens up, you have a minimum value. If the parabola opens down, you have a maximum value. Either way, the maximum or minimum value is going to be the y-coordinate of the vertex, okay? Which you already found because you found the vertex. Now the range is the y values that are getting graphed. If the function opens down, which you already know because you looked at it, then you're going to write y, and then you're going to write less than or equal to. If the function opens up, again, you already know because you looked at it, then you're going to write y, and then you're going to write greater than or equal to. Either way, you're writing y, and then you're writing your inequality, and then you're writing the y-coordinate of the vertex. If you need to state the y-intercept, which you will, the y-intercept goes with the c value in the original function, and you write the ordered pair 0, c. It is not just the number c. It is an ordered pair. And so you're going to write y dash I n t, ordered pair 0, c. Okay? So the axis of symmetry gives you the x-coordinate of the vertex. X-coordinate of the vertex gives you the y-coordinate of the vertex. The y-coordinate of the vertex gives you the minimum or maximum, and it also gives you the range. Okay? That's it. The y-coordinate of the vertex is found by using the x-coordinate of the vertex. You plug that into your function, and you get the x-coordinate of the vertex. And how do you get the x-coordinate of the vertex? Axis of symmetry. Okay. So identify all of these things. Y-intercept, vertex, axis of symmetry, max or min value, and range. How come I didn't list domain? Why aren't we finding that? Yeah, domain is always all real numbers anyway, so there's no point. All right? It's not a challenge. So y equals x squared plus 2x plus 1. What do we do? Axis of symmetry. You could do the y-intercept first if you wanted to, and that's fine. But let's do the axis of symmetry. So I write AOS, x equals what? Negative, and then b is 2 over 2 times a is 1. And then we simplify all that, and we get negative 1. So then we're going to formalize that answer. X equals negative 1. We write that directly underneath the AOS that we wrote down. And there you go. There's your answer. Axis of symmetry is done. Now what? Vertex. So to find the vertex, what do? I don't need a table because I'm not finding more points. I'm just finding the vertex. So I just plug in that number that we just found into the equation. So y equals, plug in negative 1, and I have 1 minus 2 plus 1, a total of 0. So then what I'm going to do is say vertex. And it is the ordered pair, negative 1, 0. Good. That's an answer. Put a box around it. Vertex is done. Okay, now that I know the y-coordinate of the vertex, I can do everything else. So up next, does this parabola open up or down? It opens up because the a value right here is positive. So this thing opens up, which means I have a minimum of 0, the y-coordinate of the vertex. That's an answer. Put a box around it. Min or max value is done. Now I need to talk about the range. So range. Y is, this thing opens up, so it's greater than or equal to the y-coordinate of the vertex, 0. That's an answer. Put a box around it. And the range is done. Now the only thing we haven't done yet is the y-intercept. So y dash int 0, 1. That's an answer. Put a box around it. Y-intercept is done. We did everything they asked for.
The last number plus 1, that's the one you mentioned.
Yes, the constant term is always the number that goes with the y-intercept. Yeah, right. Notice the amount of work that went into this. Okay? Everything that's an answer has a box around it. Everything that's not an answer is work. There's very little work. Okay? Okay, let's do the second one. AOS. Okay, x equals negative b, which is negative 1. So I'm writing negative, negative 1 over 2 times negative 1. Write down the negative, then find b. b is negative 1, so now you have negative, negative 1. There's a lot of negative signs. What do we have? Yeah, it's a positive 1 on top, but it's a negative 2 on the bottom, so it's negative 1/2 total. So then I formalize that. X equals negative 1/2. Put a box around it. Okay, it's a fraction. It's a bummer. We still have to work with it, and it's not a big deal. So what do we do now? Plug it in. So y equals, now, with all these negative signs and the fact that we're dealing with a fraction and the fraction is negative, I'm going to write it down. I'm not going to try to evaluate this thing in my head, okay? And that's me, which means that you probably should also, okay? So I'm writing down negative. Then in parentheses, I'm substituting negative 1/2 squared. Then I'm writing minus. Then in parentheses, I'm writing negative 1/2. When you substitute, use parentheses. Don't try to do this one in your head. It's too much. Okay, now, order of operations says exponents happens first. So negative 1/2 is being squared. What do you get? Positive 1/4. But then the negative out front says, actually, this thing is what? Negative 1/4. Now over here, we have negative 1/2, which is what? Positive 1/2. So I have negative 1/4 plus 1/2. What do I get? Positive 1/4. So actually, it wasn't hard, but it would have been very hard to get it right if you were doing it in your head. Okay? Don't be ashamed to write stuff down. It's not that bad. Okay, so what is that? That's your vertex. So I write down vertex. And what is my vertex? Negative 1/2, 1/4. That's an answer, so I put a box around it. I have my AOS, and I have my vertex. Now what? This thing opens down. So this is a max of, it's the y-coordinate of the vertex, 1/4. That's done. Now what? Range. Y is less than or equal to 1/4, the y-coordinate of the vertex again. Range is done. What am I missing? Y-intercept. What is it? 0, 0, 0. The C value is missing here. That means it's 0. So 0, 0 is the y-intercept, and we're done. And speaking of being done, that's it. This section is over.